Good morning, everyone. Welcome to today's Tecplot webinar on MATLAB and TecIO. We're going to present today a method for reading and writing Tecplot data file formats using our TecIO library directly from MATLAB. So the presenters today are myself, Scott Fowler. I'm product manager of Tecplot 360. I've been with Tecplot since 1999, and my primary role is to go out and visit our customer sites and seek feedback from all of our customers to ensure that our products continue to meet your evolving needs. Devin Simpson is our other presenter. She's a technical product engineer, and she really interfaces between our customers and code developers and really works on some of the difficult problems that our customers are having. And she was instrumental in pulling together the content for this webinar. So a brief overview of what we're going to be doing today. First, we'll give you some background. Why did we come up with this webinar in the first place? We'll give you a little bit of information on the Tecplot file formats and data types. This is really instrumental in understanding how to translate the data types that MATLAB uses to what Tecplot 360 can understand. We'll give you a brief overview of what the TecIO library is. And then finally, we'll get into some running examples of how to actually write and read Tecplot data files from within MATLAB. So first, some of the background. This all culminated back in late last year when an engineer from NASA Langley contacted us, a gentleman named Craig Street. He had developed a process in which he was reading Tecplot PLT binary files into MATLAB. These PLT files were coming as an output from the Fun3D CFD code written by NASA, and they had recently adopted our newest file format called Sizzle, or SZPLT is the file extension. And lo and behold, his scripts broke, and he called us and needed a way to get his data into MATLAB. So the TecIO library had recently been updated to allow reading of SZPLT files. So Devin and I put our heads together and figured, gosh, if we can figure out a way to use the TecIO library within MATLAB to read those files, this could be a great solution for Craig. And that's what we developed, and that's what we're going to be showing today. And for Craig, this was a really big win for him. Not only was his process more reliable because his previous process did fail on occasion, but it's also 3 times faster. So big win for him, and we're going to share the results of that work with you today. So at this point, I'll hand it over to Devin Simpson, and she's going to tell us a little bit about when you would use 360, when you would use MATLAB, and then the rest of the technical presentation.
Thanks, Scott, for the introduction. So the first thing I kind of want to cover is why 360 and why MATLAB and how they work together. 360 is really a good product for interactive data analysis with presentation quality plots, particularly if you're using simulation data. If you've got any type of 3D volume line data, that works really well in Tecplot 360. However, the back end is very structured data format. It's very dependent on the mesh, which is similar to computational file formats, and works well to get very quick understanding of 3-dimensional data. On the other hand, MATLAB, a program that pretty much every engineer has touched at least once in their career, gives you very good programmatic data control of the actual data. In MATLAB, everything's a matrix where you have access to slice the data in various dimensions, do calculations. However, it also has kind of limited 3D plotting capabilities, so quite good 2D plotting capabilities, but it's not super interactive. You have to do everything through commands and such. MATLAB also has very good test data acquisition and processing tools from for systems and such. So commonly, engineers will have to use both Tecplot 360 and MATLAB in a process, particularly if they are looking to compare simulation and test data processes. So that's, today we're really looking to share how to get your data between the two formats using Tecplot file formats. So the building block of Tecplot is really the zone. And a zone is a region of data points defined by a mesh. It can be 2, 3, or 1 dimensions. And there's 3 different kind of classes of zones. Ordered zones, where it's implicitly defined by connectivity. This is very similar to MATLAB's matrix is in 2 and 3 dimensions. You can see in the image to the right, you've got ordered values and indices going in each dimension with values at each of these points. Then getting a little bit more complex and complex structures, you get finite element data, where the mesh is defined by a connectivity list. So in the case off to the right, you've got every single point in this mesh is defined by a connectivity list between 3 points. 977 is then connected to 1570, which is connected to 1795. And this defines the whole mesh. You then get into polyhedral data, where bases and connectivity are more complex. We're really going to be concentrating today on the ordered and finite element data, which is easier to get in and out of MATLAB. After zones come data sets, which are just a collection of zones and variables and then the points for each of the, at each of the values. You can kind of think of a data set as a 3D ragged matrix, where zones are 1 dimension, variables are another, and then the values for each of the, that define the zone and the variable are the 3rd dimension. And this means that when translating data between MATLAB and 360, you're going to have to be defining it as a vector, a 1-dimensional vector into the into this screen, kind of as in the image on the right. So after data sets, you can kind of, once you've created your data set, you'll need to define it into a file. Tecplot has 3 different file types. The first is Tecplot ASCII, which is typically has the .dat extension. This is a very easy to write tabular format, very similar to CSVs, with space or comma delimited, with a simple header that defines variable names, zone names, and then a little bit of information about the zone type. Unlike CSVs, you can have multiple zones in the same file. So simply putting the zone header multiple times in the file you can create multiple lines. Tecplot ASCII, I would very much, is a lot easier and more user-friendly to use. So if you're using small data or just trying to translate lines between 360 and MATLAB, I encourage using Tecplot ASCII data format. On the getting into more complex area, you will get the Tecplot binary formats. .plt and .szplt are our 2 formats. PLT is kind of industry standard. It's been around for many years and is written out and read by many different products in the industry. Our newer format, .szplt, is what we're going to be concentrating on today. And we're trying to push this one because it's a lot faster read into Tecplot 360. And TecIO can both read and write szplt. So we've been throwing around TecIO throughout this presentation. What is it? It's a compiled library, C library, which can access the information in the TecIO binary files. It can write both SCPLT and PLT files. However, it can only read the SCPLT files. Here are some examples of functions in the TecIO library. TecZone get title, TecZone get IJK, both with input and output arguments as presented by the, this is how MATLAB will see, you'll see it in MATLAB. At this point, you've kind of got enough background to go forward with some of the demos in MATLAB. We're going to be going through, I'm going to be going through 3 demos. The first is an ASCII format. The second will be bringing the MATLAB logo surface into Tecplot 360 for more complete image generation. And then finally, we are going to be looking at a CFD solution of some blade roads bringing that information into MATLAB. So we'll jump over to MATLAB at this point. So this is our first function, our first MATLAB file. We're going to be looking at SunspotsDAT, which is a data file that is included in the Tecplot distribution, or the MATLAB distribution. It merely is an array n by 2, where the first dimension is the year, and the second dimension is the number of sunspots seen in the recorded history. So as we go forward, we're going to be looking to write a Tecplot ASCII file. And as you saw before, it's a very simple text file. So we'll just be using the MATLAB's fopen command and then fprintf commands to open the file, which you can see was generated over on this side when I stepped over the open command, and then writing the simple elements to the file. So the first element of the header is giving the variables names, and then we'll be giving the zone information here. Each zone, in this case, we're looking to create a 1D line zone. So the connectivity in this case is going to be just an I-ordered zone, which is the first dimension. J and K are then 1, and even though it's an n by 2 matrix here, we're only going to, the second dimension goes into the variable column instead of going into a second dimension of the zone. So writing out to the file, we've got the zone name and then the IJK dimensions of an ordered zone that we just defined in the function. After the header, we're going to give the data points themselves. So in this case, we're going to loop through all of the points and then loop through each of the variables for each point, giving some spaces and new lines between each of them. So after it goes through all of that, we should have a file here that is easily recognizable from the image before, and I could just load this into Tecplot and run it and see lines just as easily as I could in MATLAB at this point. Our next demo is to show how to bring a more complex data point into Tecplot. In this case, we're going to be working with a surface. These first 4 lines are MATLAB calls to create a Z matrix of 201 by 201 and then generate a surface in 3 dimensions. This surface we want to bring into Tecplot so that we can do more advanced analysis or visualization of it. And so first we need to get into a way that Tecplot can handle it. So again, we're going to be defining the I, J, and K of the values of the matrix. In this case, it's just going to be 201 by 201 and 1 because it's a surface data set. From there, we're going to calculate the number of total points, which is simply I times J times K. And then, although in this case, MATLAB was able to intrinsically use the positions of the values in the matrix, Tecplot needs to have the X and Y coordinates. So the combination of linspace and mesh grid will generate two 201 by 201 matrices here that define all of the X and Y coordinates of each point for the Z variable. If you recall from before, of each of the values arrays in Tecplot needs to be a one-dimensional vector. So that's what we're doing in this step. We're going to the total number of points by 1 and just reshaping X, Y, and Z into these 40,000 by 1 vectors. The final step of this is just a convenience so that we can loop through each of the X, Y, and Z later once we try and load it into Tecplot rather than calling them individually. Now that we've got our data into a form that Tecplot can handle, we can go ahead and load our TecIO library. TecIO can be found in various places. The easiest place to find it is in the Tecplot installation, but it's also available for download for free on our website where you can have access to the DLL and the header files. So in this case, we're going to be using the one from my installation. I'll step over these functions, which set up the location where I'm looking for it, and then using the MATLAB's load library function with the DLL or with the location of the DLL and header, we can load the file into the library into MATLAB. To ensure that it's loaded, MATLAB also provides this libfunctions view, which launches a dialog with all of the return types, the function names, which we've got over about 1,000 different functions to access and create data in Tecplot binary data files, and then also the input arguments and their types. So once the file is loaded, our first function is here. Our first call into the TecIO library is here, which will just simply open the file, just like we were doing before. For this function, we're going to provide some information, like the file name we're expecting to write to, the dataset title, which is just kind of something that is a global title of the dataset, each of the variable names. In this case, it requires a comma-separated string, so we are given X, Y, and Z here. And then a few other simple information like, are we going to be exporting it as a PLT or SZPLT? We're looking to do an SZPLT, so our value is 1. File type is something more for solvers, so we're going to be where they would like to separate the grid and the solution values. We're going to be providing both in the same file, so that will be 0. And then MATLAB's default data type is a double versus single precision data, so we'll be matching it with 2. You notice that we've got a couple extra parameters here. For this thing, we're looking to, it doesn't matter at this point for what those are. MATLAB and the call lib use the brackets as passing null. So that's what we're passing here. our output of this function is going to be a file handle that we're going to be using throughout the rest of our calls to TecIO. So after we step over that, we've opened a file in a file handle that TecIO is going to start writing to. At this point, we're going to be setting up the motor zone information by using TecZone create IJK. The main information we need for this is the file handle, a zone name, the IJ and K dimensions, which were defined above, and a pointer to where the zone index will be returned. In this case, we're kind of giving it a hint to 1, but it will also return 1. The rest of these values can be null or 0 because those are really more advanced things for more advanced solvers. We're using a single zone, so we can ignore those at this time. Now that the zone base has been set up, we're going to go in and set up all of the variables. This vars is what we set up here with the X, Y, and Z vectors all together in one list. We're going to loop through each of those, so it should be looping through 3 times for each of the variables, and then write double values to the zone that we had just set up and for the variable index that we're looping through. Conveniently, MATLAB and TecIO are both 1-based, so we don't have to worry about off by 1 issues here. This function also requires the total number of points in this zone, as well as the, and then we can pass the actual values using just a regular matrix of MATLAB matrix. So as we step over that, we can actually, once that's complete, we can just close the file and unload the library. And the sizzle file just appeared here called logo.seplt. To prove that this is actually what we were intending to load, I'll open it in Tecplot 360, and because it's a surface, it automatically brings it in as a 2D Cartesian, but we'll switch into 3D Cartesian mode, and we can see this looks pretty similar to our MATLAB logo, and I can do everything I would be able to do in Tecplot 360 at this point.
I'll just quickly point out that while Devin did note that the TecIO library has thousands of functions, you can see in this example it only required about 4 function calls to the TecIO library to create the data set. So pretty simple set of functions to call.
Yep. Our final demo today will be actually loading a CFD solution into MATLAB and just showing a few different functions that are available to get the data out of the sizzle file. There's a lot more available, but we'll just be showing a handful of things there. So you can see this TecIO setup's exactly the same as the previous file, so I'll just step through that quickly. At this point, TecIO is loaded, and we can start doing our reading. So the first function is file reader open. And that just takes a file name and then a null pointer so that we can get the file handle out again as we did in the previous example. So all Tecplot data sets have zones and variables. So the first thing that we're going to be looking for is the number of zones and the number of variables in this data set. So passing those to the text dataset get num vars and get num zones, we can get the number of variables as 25 here, and then the number of zones as 176. So to get more data out of each of these zones and variables, we'll loop through the zones by just going 1 to the number of zones. And as we were discussing before, each zone will have a type. And this is going to be returned as an enumeration where numbers are defined as, numbers define the explicit type. In this case, we're looking at a data solution where the type is returned as 5. And using the Tecplot data format guide, we know that 5 will mean FE brick. This function, we simply pass the file handle, the zone number, and then the handle back to what we would like to the type to be. If this zone had been an ordered zone, we could get more information like the ij and k indices. This, however, this data set does not have any ordered zones, so I, J, K are going to stay undefined as we step through this. After we get a little bit of information out of the zone, we're also want to get the actual values associated with each of the points. So to do this, there's 2 TecIO calls that are required. The first one is TecZone var get num values, and that will return the number of points of this zone. In this case, num values is now 38,360. We will then allocate an array kind of so that TecIO can use that to populate it. We'll be passing that into TecZone get float values with the handle, the zone variable, the type this is the data type, the number of values we're expecting to get out, and then the array that it's actually, or matrix that it's going to be populating into. So stepping over this, we can now see values is populated to that size, and open it, and we can now see that this array has multiple values to it. Because this is an FE data set, you would also need to query the connectivity list to really make sense of this. But because this is the first variable out, we can pretty safely say that this is the X values of this zone, which are pretty consistently 0.37. From there, that's just kind of a sample of how to get the values out. The next kind of more complex thing to get out is actually strings. In this case, we're looking to get the data set title out. This is the same way you would get zone names, variable names out. This is probably the most complex thing for us to figure out. We had to ask MATLAB support how to get this, but because MATLAB does not support strings as part of matrices, we have to use the cell type. And using the call lib, it needed to be a pointer. So to create that cell pointer, you use the lib pointer call with cell, an empty cell, which then creates, which then passing that to the dataset get title call will return the actual dataset title. In this case, the title is axial data. Now we've just kind of sampled how to get some of the data out of this file. At this point, it's not very useful, but using Tecplot extractions and more complex extractions in MATLAB, you can really get into the solution of your data set by going through using this TecIO library. At this point, we'll close the file on the library, and that will be the end of today's demos.
Thanks a lot, Devin. Yeah, I just wanted to point out a couple other things that that may have been missed. So the TecIO library is a C library. We also have a Fortran version of it, although that doesn't much matter for use within MATLAB, at least not with the C library capabilities. We do have that library available in both static and dynamic library versions, and as Devin pointed out, it's available in the Tecplot 360 distribution. It's also available for download on our website. We do have obfuscated source code available if you do need to compile it for other operating systems that we don't intrinsically support. All of the information on the function calls is available in the Tecplot data format guide, which again is part of the Tecplot 360 distribution. So I'd like to open it up for questions. We already have a few that have come in, and so I'll answer these verbally as quickly as I can. Will these MATLAB files be available? Yes, we'll go ahead and share these MATLAB scripts along with the recorded webinar a couple of days after this webinar is complete. Can you explain how to dump my parallel computing results from MATLAB to Tecplot? I guess the short answer is no, I can't. We do have a TecIO MPI library, so that's an MPI-enabled version of the TecIO library. We have not done any testing with MATLAB to see how this would interact. But I would encourage you to take a look at the MPI version of our library, and feel free to contact support, and maybe we can figure out how to help you out there. Let's see. How does TecIO iterate through the rows of the vars matrix? This was Devin. If you go back to your example, the writing example, MATLAB logo.m, when you're looping over the vars variable towards the end.
So we've got vars as a 1×3 matrix, and then as we loop through it, we actually have to pass them individually. I just created it as a single matrix so that I could create a loop and not call this for each of the variables. So I could just use the index of the variable I'm creating in this vars setup here.
Okay. There's a lot of reference to the word is okay in these call lib functions, and the question is that an error code? And the answer is yes. Each TecIO function call will return an error code, and so we're capturing that there. Of course, these scripts don't have any error checking, but to write a robust script, you'd want to check those error codes.
And then it was quite helpful for debugging for myself. There were several times where passing something subtly different is okay would be not 0, which is the okay state. It would be -1, which is the bad state.
Okay. Are the calling functions similar in Fortran once one figures out how to access the necessary DLLs? I don't know. We haven't done any testing with the Fortran version of the TecIO library, so we've only focused on the C library. So I guess that would be future research. Any plans to consolidate the functionality of these MATLAB scripts into one line TecIO function, i.e. load data file XXX? Yeah, so we've talked about that a little bit, about how it would be certainly nice to have simpler function calls over all of these call lib, because the syntax here is a bit cumbersome. And yeah, we've talked about that possibility. And for any of you who are online today that are interested in a better integration with MATLAB and TecIO, I encourage you to contact us, and so we can further the discussion. Do these ASCII files still load into Tecplot slowly? Yeah, so that's a really good question. We did mention that early in the webinar that ASCII is recommended for small data. Tecplot deals with binary data natively only. So whenever we load an ASCII file, we do have to go through a process, or Tecplot 360 goes through a process of converting ASCII to binary. So if you have a lot of data that you're going to be processing, you definitely want to prefer the binary data files. So ASCII, good for small data, but if you have a lot of small data, you may want to convert to binary.
And to add on to that, there's several ways in other documentation on how to convert ASCII files directly to binary PLT and SZPLT. Check out information on using the -convert flag with command line options might be a good option. If ASCII is still simpler to write out, but you're looking for the performance of binary.
Okay, let's do 2 more questions here, and then we'll call it. So, is the C library callable from MATLAB without the C compiler? The answer is yes. Now, Devin does have a compiler installed on this machine, but there's no reason that you need a C compiler installed to use this MATLAB capability, the call lib and load library functions. And then, is it possible to get butterfly plot using Tecplot 360 synced with MATLAB? I have to admit, I'm not quite sure what you mean, so maybe we can follow up post-webinar. So, well, I hope you all learned something today. We certainly had fun doing this work and helping out a customer, and yeah, I hope that we can continue the conversation on how to integrate Tecplot 360 and MATLAB together. They both have great attributes, and you know, as they say, like peanut butter and chocolate, two great tastes taste great together.
One more note is that a lot of this documentation on how to use TecIO can be found in the data format guide, also in the Tecplot installation, as well as the website.
Okay. Thank you very much.